right here at talking about number systems is what we're going to start with. So we're looking at, we've got these numbers at the top. Hopefully you can see them. We've got 8, 7/3, negative 3.1, the pi symbol, 2.175, negative 7, square root 2, 1000.00005, and 0.16 repeating. And we're just going to place them kind of in this chart. Again, just for the record, this diagram is no way conveys the actual size of the sets. In mathematics, the number of elements that belong to a set is called the cardinality of the set. Technically, and with a lot more mathematics behind you, it can be proven that the cardinality of the irrational numbers, uncountably infinite, is actually larger than the set of rational numbers. So just don't judge the size by how many things can fit in it. It's really just to fit on this paper. Okay, so we've got 8. Now, natural numbers are 1, 2, 3, 4, 5, going on up. Whole numbers start at 0 and go 1, 2, 3, 4, 5. Integers, we can have negative numbers. Rational numbers are numbers that don't necessarily fit in these steps, but it's still rational. And then irrational numbers, like you cannot change it into a fraction. And then all of these are real. Okay, so we've got 8. 8 is a natural number. It's also a whole number. It's also an integer, rational, real, and irrational. It is not an irrational number, though. 7/3, it's not a natural number, not a whole number, not an integer. It is a rational number. It's written as a fraction. Negative 1.3. Now, it is a negative number, and some people go right to its integers, but it has a decimal point, so it must be a rational number. Pi, on the other hand, is a non-repeating decimal. It goes on and on forever. They have not found the end of it, so it must be irrational. 2.175 is a rational number. Now, negative 7 is an integer and a rational number. Square root of 2, if you put this in your calculator, it'll give you a decimal, but it will go on and on and on and on. So the square root of 2 is irrational. 1,000 is a natural number. It doesn't include, it's not 0, so 0 would be the whole number here. But it is, and it's not a negative, and yeah, so it fits there. 0.00005 is a rational number. And 0.16 is also a rational number. It's a repeating decimal, so we can change that into a fraction. Now we're going to look at these questions at the bottom and just kind of answer them. We've got, given all the possible real numbers, name at least one number that is a whole number, but not a natural number. That would be 0. 0 is the only number that is a whole number, but not a natural number, as long as we don't go to negatives. Can a number both be rational and irrational? The answer is no, it can't. Can a number be both rational and an integer? Yes. An example would be like negative 1. Given all possible real numbers, name at least one number that is an integer, but not a whole number. Again, we could choose negative 1. Any negative number. Okay, so this is just talking about different number sets and some qualifications.